Okay, so today we are going to go backwards, okay? We have 4 properties that if this is the case, then we know the quadrilateral is a parallelogram. Okay, so if the opposite sides of a quadrilateral are congruent, then we can say, yep, that's a parallelogram. So if we have a quadrilateral and it looks like this, that's all the information you have, then we can assume, yes, that is a parallelogram and it has all of the other properties. Okay. If we have a quadrilateral and the opposite angles of our quadrilateral are congruent, then with that one condition, we can say, yep, this is a parallelogram. Okay, so what's the next one going to be? If the diagonals, of a quadrilateral, not congruent, if the diagonals do what? Bisect each other, then we know our quadrilateral is a parallelogram. So they have to bisect each other. Oh, shoot. I was going to go over that problem. We'll do it after notes. Thank you. Did you really? All right. Now, this one is not one that we talked about yesterday. This is a specific one to this going backwards, like, is it a parallelogram or not? Okay. So if one set of opposite sides one set of opposite sides of a quadrilateral are both congruent and parallel, then we have a parallelogram. So one set of sides, both congruent and parallel, but it has to be the same set of sides. Okay, so make sure you get the picture drawn like I have. Thank you. Really?
That's cute.
Okay, so using these 4 properties, I need you to be able to tell me whether we have a quadrilateral or not. So, this first one right here, is it a quadrilateral?
Yes.
Okay, and our reason would be, okay, what? Did I say quadrilateral? Thank you, Jay, for putting me straight. Is this a parallelogram?
Yes.
Yes, because our opposite sides are congruent. Okay. I might put both. Okay. How about this second one? Is this a parallelogram?
No.
Yes.
There's one set of sides.
Yes.
Is A the same? Both of them are A. So yes, because one set of opposite sides are both parallel and congruent. I can see where you thought that might have been Mr. Reese. Did somebody DoorDash? Man. Okay, how about this third one? Is this a parallelogram? Yes. What's the reason? Hey, it's been pretty mild today, right?
Yeah. Nothing's loud.
I say that, and now it's gonna really ramp up. Okay, and how about the fourth one?
The DoorDash person's leaving.
Okay, our opposite angles are congruent. I hope they got it.
Do you have somebody in this car?
Yes, he does.
There was a person that dropped
I
off
missed
her
my blinds.
groceries, and his name was Peg.
All right, so I need you to be able to look at a quadrilateral and tell me, is it a parallelogram, yes or no? Why or why not using these four properties? Now, I also need you to force quadrilaterals to be parallelograms. So go to the next page. Force them.
Four. Then get it. Four sides.
I do.
Oh yeah.
Okay, so I'm going to give you 60 seconds to work with your elbow partner to force example 2 to be a parallelogram. Ready, set, go. Force it.
You didn't steal anything. You just put it on the floor. Thank
Yeah. Oh yeah. What's
What do you get for X
Just do example 2. And I probably gave you longer than 60 seconds.
120 minus.
So that's 100.
So it's 8.
No.
One angle has to be 2 angles.
All right, Corbin, what'd you get for X? Okay, Corbin got X equals 40. Okay, Luca, how did you get X equals 40? What'd you do?
4x plus 20 equals 180.
So, do you mean 3x minus 20 plus x plus 40 equals 180?
Yeah.
And that's how you got 4x plus 20 equals 180?
Yeah.
Okay. Oh, got it. Okay, just, I mean, this is fine, but yes. Okay, now, how do I get y?
You have to.
What do you do, Noah?
You plug in 40 to the 3x minus 20, and then do the opposite angle.
Oh.
Opposite angles.
Okay, so what is 3 times 40 minus 20?
Something.
100? So we know that 4y equals 100. So y equals
25.
25. Did anybody use x plus 40 and do the supplement?
Yeah.
Yeah. Potato, potato, it doesn't matter. Thinking is okay. All right, I want this guy to be a parallelogram. I have QU is 18 and US is negative x plus 1. What will we do? What do I do with the two?
Equals negative x plus 1.
Yeah, so 17 equals
Negative 17.
How does 17 equal negative 7?
I don't know, Billy just said 17 equals negative 17.
Wait, did I not say it right?
I don't know.
I thought it was
It's okay. He just gets so excited. Oh, Kayla, you're having a rough day.
No, I just got some answers wrong. And
Oh.
assume that means I'm having a bad day. I'm on top of the world.
We are allowed to make mistakes. Okay. Now, let's talk about if I give you 4 coordinates in the coordinate plane and I ask you, hey, is this a parallelogram? There are 4 different things that you could do to figure it out. Okay? If the diagonals bisect each other, like we saw in our warm-up, what happened to our diagonals? They have what? The same midpoint. Okay? So what you could do is you could find the midpoint of one diagonal, the midpoint of the second diagonal, and if they are the same midpoint, then that means our diagonals are bisecting each other, and yes, we have a parallelogram. Okay? Or we could use the slope. What would the slope help us figure out? If opposite sides are parallel, then opposite sides have the same slope. We would have to check both pairs. So how many slope formulas would we be doing?
2. 4.
4. Okay. So here we would be doing 2 midpoints. Here we would be doing 4 slopes.
Oh, because you have to check all 4 slow. Oh, I see.
Yep, because both sets of sides. Okay. Now we also have the property that if both sets of opposite sides are congruent, we would have a parallelogram. So if opposite sides are congruent, then we know that opposite sides would have the same length. Which means we would check the distance for all 4 sides to figure out, are both sets of opposite sides congruent? Are they the same length? Okay. Then that property we talked about today, where there's just one set of sides that are congruent and parallel. Okay. Then what we could do is we could just pick one set of sides, okay? And we would need to make sure that they have the same slope and the same length, which means we would take one set of sides, we'd find two slopes and two distances to make sure that this was happening. Okay, so what I did is I put an example at the bottom. And what we're going to do is we're going to do the same problem 4 different ways, which I know sounds annoying.
I hate calculating distance.
We will work together, okay? So here's FGHJ. If I want to use the midpoint method, I need to find the midpoint of which two segments? FH and GJ. Okay, so you know what? We're just going to split up the work. If you are, if your last name starts with A through M, you are going to find the midpoint for FH. The rest of you will find GJ. You have 30 seconds.
Let's go, Noah Z.
What?
We got this.
You got this, Phil.
Yeah,
Goes, yeah.
you 3 are all finding the same one.
Her last name is Palmer.
Even if it was, you would still be after
Let's
M.
not go Palmer.
Yeah.
Whose name's Palmer?
Yeah, so,
My name's-
so Y is 1. Y is 1. Yeah, okay. And then the other one is... Yeah, that's what I just said.
That one's like 3 points.
Wait,
No, but there's no 1.2.
Yeah, 4 points. 9 halves, comma 1.
you're right.
Oh, wait, no.
Okay, beginning of the alphabet. What is FH's? Oh, I'm sorry.
No, you're still even copying off me. What the heck, man?
What?
I guess not then.
I would say not.
9 halves and 1.
I'm hearing 9 halves, aka 4.5, comma 1.
Oh, yeah, that was Alexis.
What about the second half of the alphabet?
Wait, 4.5.
That means they're her.
4.5, comma 1. Oh, look at that. We have the same midpoint for our 2 diagonals. So yes, this is a parallelogram. Okay, so we know that the rest are going to be, yes, parallelogram. Hey, Kale, did you happen to maybe use the wrong 2 coordinates?
Yeah.
Okay. So make sure you're paying attention to, if we're doing diagonals, right, we have to like skip over like every other letter is what we're looking at. Okay? All right, so now we're talking about slope. We need to check, if we're going to use the slope method, we need all 4 slopes. So we need the slope of FG. We need the slope of GH. We need the slope of HJ. And we need the slope of JFFJ, however you want to say it. Okay, so here's what I'm going to have you do. Blue table, FG. Okay, purple and yellow, GH. Okay, red and teal, HJ. Green table, FJ. Find me the slope, please.
Y2
Rise over run.
1
Yeah,
over
yeah.
X2 minus x.
Yep, here's the slope formula to help you out.
3 minus y, y over 3 minus 0. So it would be like
Negative 4/3.
no, so 2 plus 1. Because y
No, I had to copy off Billy again.
I did not. I could work right here.
That'd be a first.
Over 8 minus 6. 2 over 3.
Dang it!
So what are you guys getting? Yeah.
It doesn't matter. It's the same thing.
Yeah.
Oh, no.
Okay, blue table, what are you getting for FG? Who said they didn't? Okay. So
Oh, I did not do it right.
you should be taking 2 minus 3 over 8 minus 3. There we go. Okay. Now, who is this guy going to be parallel to? Which one? HJ. Okay, HJ, what'd you get for your slope? Red and teal. HJ. Yeah.
We had GH. We had GH, and they should have had HJ.
Yes. Okay, so what's GH?
I got 3 over.
So we need to keep it as 3 over 2. Don't change it to a decimal. Okay?
I got 3 over 2.
Yeah. Yeah.
I did 2 plus 3 over 8 minus 6.
Oh, wait, I did 2 plus 3, not 2 plus 1.
There you go. Okay, HJ, what did you get? Negative 1/5. FJ, 3 over 2. Okay, so do you see how these two are the same, so they're parallel? These two are the same, so they're parallel.
So it is congruent, or not congruent?
We have a parallelogram.
Oh, that's cute.
All of them are going to be parallel.
I know. We know it's a parallelogram. I know. But I wanted you to see what it looks like. Is that fair? Okay. Now, if we're going to use the distance method, we got to find the distance of each of these. So, blue table, can you find me the distance of FG? Purple and yellow table, the distance of GH. Red and teal, you're the distance of HJ, please. And then green table, the distance of FJ. Remember the distance formula. There's a distance formula if you forgot it.
What did you guys get?
Yeah, we're doing it.
I did. 13. I got 36. Get it wrong. It's 26. Radical 2 plus 3 is 1. By the way, what did you
Oh, wait, no.
Yeah, no, that was.
We're still doing
What is radical? What is radical?
I say that.
Square root?
That's what it means?
Yeah.
Did you guys get radical 26?
Yeah.
Why are you saying just
Why was it square root?
Square root of what?
26.
Okay. Sneaky. All right, FG, we got the square root of 26. GH.
13.
Square root of 13. HJ. 26?
Yeah.
So, and FJ, square root of?
13.
Oh, look at this, guys.
Yo.
These two are congruent, and these two are congruent. So, yes, we have a parallelogram. Okay, now, if you're going to use this method, you're going to pick one pair of sides. So let's pretend we pick FG and HJ, right? What we would do is we would find the slope for each of them, okay, which we have already calculated. And we would find the distance for each of them. And if both slopes and distances match, then yes, we have a parallelogram. Okay.